During World War II, engineers from the home front to the front lines turned bold ideas into reality. The M4 Sherman was more than just a standard medium tank. It served as a highly adaptable, universal platform. From this reliable base, the military created some of the most amazing and specialized machines of the era. They didn't just build tanks, they built problem solvers. Whether it was clearing heavily mined beaches, breaking through impassable hedgerows, or neutralizing fortified concrete pillboxes, standard armor was often not enough. Today, we are breaking down 7 of the most incredible M4 Sherman modifications. These are the engineering marvels that completely changed armored warfare. Let's dive in. The Sherman Jumbo, officially the M4A3E2. As Allied forces pushed deeper into Europe, they encountered a severe armored threat. The standard Sherman simply did not have the armor to survive direct hits from the high-velocity guns of German Panthers or the heavy 88mm cannons of the Tiger tanks. To solve this imbalance, engineers created a dedicated assault tank. They took a standard Sherman chassis and welded an extra 1.5 inches of steel to the front hull. But the most significant change was the turret. The Jumbo featured a massive, newly designed cast turret with armor up to 6 inches thick, protected by an incredibly heavy 7-inch gun mantlet. All this extra steel pushed the tank's weight to over 42 tons, requiring specialized track extensions known as duckbills to prevent sinking into the mud. Tactically, the Jumbo was indispensable. It drove at the very front of the armored column as the point tank. When a hidden Panther or Tiger opened fire, the Jumbo was built to take the hit, deflect the heavy armor-piercing shells, and reveal the enemy's location. Once the threat was exposed, the rest of the column could maneuver and neutralize the enemy armor. Because of its incredible survivability against Germany's heaviest tanks, the Jumbo became highly prized. Only 254 were built, but their ability to spearhead assaults made them absolute legends. The Sherman Crocodile and Zippo. While the Jumbo was built to absorb heavy hits, these flamethrower Shermans were designed to deliver devastating strikes against even the most heavily protected positions. These modifications replaced standard machine guns or main cannons with heavy flamethrower nozzles. The true engineering challenge, however, was safely storing the highly volatile fuel mixture. To solve this, the flammable liquid was stored in specialized armored cylinders. In the British-designed Crocodile, these massive cylinders were housed in a heavy, towed armored trailer behind the tank. American Zippo variants often integrated these cylinders internally. In combat, these machines were terrifyingly effective. When standard artillery couldn't penetrate a bunker, the flamethrower Sherman would drive right up to the firing slits. It projected a stream of liquid fire that could bend around corners and reach deep into fortifications, instantly neutralizing the hidden positions. Strategically, mounting this weapon on a Sherman was a massive upgrade over infantry flamethrowers. Infantry operators carrying heavy cylinders on their backs were highly vulnerable to snipers. By placing the system inside a multi-ton armored vehicle, the crew could advance safely and dismantle the toughest defensive lines. The Sherman Crab. One of the most immediate threats to any advancing army is the hidden minefield. To solve this, engineers developed the Sherman Crab, a highly specialized mine flail tank designed to carve safe paths through heavily trapped territory. The design was brilliantly brutal. Mounted on 2 extended steel arms at the front of the hull was a heavy rotating cylinder. Attached to this cylinder were 43 heavy steel chains, each ending in a solid metal weight. When engaged, the tank's main engine powered this front cylinder, spinning it at approximately 140 revolutions per minute. As the tank moved forward at a deliberate speed of just 1.5 miles per hour, the chains continuously hammered the ground with immense force. This physical impact safely detonated buried anti-tank and anti-personnel explosives several feet ahead of the vehicle. In addition to clearing explosives, the outer edges of the rotor were equipped with specialized blades that easily tore through thick barbed wire entanglements. Operating the Crab was an intense experience. The constant frontline detonations threw up massive clouds of dirt, smoke, and debris, severely reducing visibility. The crew had to rely on internal instruments to maintain a straight lane for the units behind them. Despite these harsh operating conditions, the Sherman Crab was incredibly effective. First seeing major combat during the 1944 Normandy landings, it became a vital asset. By rapidly neutralizing minefields, the Crab ensured that standard armored columns could maintain their advance without being stopped by hidden traps. The Sherman T34 Calliope. While the Crab dealt with hidden threats on the ground, the Calliope was designed to unleash absolute devastation from a distance. This modification turned the standard medium tank into a highly mobile, heavy multiple rocket launcher. The visual profile of this vehicle was unmistakable. It featured a massive frame holding 60 launch tubes positioned directly above the turret. The engineering brilliance lay in its integration. The entire launcher frame was physically linked to the Sherman's 75mm main gun barrel by a solid mechanical arm. This allowed the gunner to use the standard turret controls and optics. By elevating or depressing the main gun, they aimed the rocket launcher. The turret could also traverse normally, providing a wide field of fire without needing to reposition the entire multi-ton vehicle. In combat, the Calliope fired 4.5-inch M8 rockets. A single tank could ripple fire all 60 rockets in rapid succession, completely blanketing an enemy position. This massive barrage was highly effective at neutralizing heavily fortified areas and dismantling defensive lines just before an infantry advance. Beyond the structural impact, the Calliope delivered a profound psychological shock. The sheer noise and visual spectacle of 60 rockets screaming toward a target shattered enemy morale. Although the top-heavy launcher made the tank a high-profile target, the ability to deliver such concentrated firepower made it an unforgettable force on the battlefield. The Sherman DD, or duplex drive, amphibious assaults present a massive logistical nightmare. Getting 30-ton armored vehicles onto a contested beach usually required bringing vulnerable landing craft right to the shoreline. The Sherman DD was created to completely rewrite that rulebook. The concept was incredibly audacious, a tank that could swim. The DD modification relied on a massive, heavy canvas screen attached to a platform welded around the tank's hull. When inflated by compressed air cylinders, this screen rose several feet above the deck. This canvas displacement hull provided enough buoyancy to keep the 30-ton Sherman afloat. But it wasn't just a raft. The duplex drive name referred to its dual propulsion system. The tank's main engine could power both the tracks for land movement and 2 rear-mounted propellers for water navigation. During the Normandy landings on D-Day, these amphibious Shermans were launched directly from landing craft miles off the coast. As they navigated the choppy English Channel, only the top edge of the canvas screen and the commander's head were visible above the waves. From a distance, German defenders assumed they were just small rubber boats. The shock effect was immediate. As the tanks touched the sand, the crews quickly deflated the canvas screens, instantly revealing fully armored Shermans, ready to provide immediate fire support to the advancing infantry. The Sherman Rhino. After the successful Normandy landings, Allied forces faced a completely unexpected enemy, the French bocage. These centuries-old hedgerows were massive earth banks filled with incredibly dense roots. When a standard Sherman tried to cross one, the tank had to climb up. This maneuver dangerously exposed its thin, unarmored belly to hidden German anti-tank weapons waiting on the other side. It was a tactical nightmare that completely halted armored mobility. The solution didn't come from high-level engineers, but from a soldier on the ground. A sergeant named Curtis Cullen had a brilliant idea. Soldiers gathered the heavy steel beams from German anti-tank obstacles, known as Czech hedgehogs, which still littered the landing beaches. Field mechanics cut these massive steel beams and welded them directly to the front hull of the Sherman, creating a set of sharp, forward-facing tusks. This ingenious field modification gave birth to the Rhino tank. Instead of climbing over the hedgerows, the Rhino could literally cut and bulldoze its way straight through the thick earth and roots. By recycling enemy defenses, Allied armor broke out of the bocage, safely restored their mobility, and regained the element of surprise. The Sherman Dozer. Not all battlefield challenges required massive firepower. As the Allied advance pushed into heavily damaged cities, the greatest obstacles were often mountains of rubble and disabled vehicles blocking narrow streets. To keep supply lines and armored columns moving forward, the military introduced the Sherman Dozer. By attaching a massive, hydraulically operated M1 bulldozer blade to the front of a standard medium tank, they created the ultimate armored workhorse. In urban combat, this modification was completely invaluable. It could rapidly dismantle barricades, fill in deep anti-tank ditches, and push knocked-out heavy armor safely out of the way, all while keeping its crew protected from incoming fire. It wasn't the most glamorous attachment, but the Dozer was an absolute necessity for sustaining the Allied momentum. From carving safe paths through minefields and surviving direct hits to swimming across the channel, the M4 Sherman proved it was much more than just a standard tank. Its remarkable ability to adapt to any battlefield challenge cemented its legacy in military engineering. World wars, despite their immense destruction, have always been catalysts for rapid innovation and brilliant engineering ideas. Highly versatile platforms like the M4 Sherman perfectly assisted in this, proving that a single, reliable chassis could be adapted to overcome almost any impossible battlefield challenge. Which of these Sherman modifications did you like the most, and which one do you consider the best and most useful? Let us know in the comments below, and subscribe for more historical deep dives.